Rocket fuel is indeed very expensive. So, when traveling among the planets, it would be a good idea to minimize the amount of fuel required by the spacecraft. A fuel-efficient way to launch a spacecraft to an outer planet is the Hohmann transfer orbit. In this video, we will learn how to launch a spacecraft to an outer planet, for example Mars, with the lowest amount of fuel possible and in an energy-efficient way. According to Kepler's first law of planetary motion, all planets revolve around the Sun in elliptical orbits. The position which is closest to the Sun is called the perihelion, and the position which is farthest from the Sun is called the aphelion. Planets in their orbit move faster when they are near to the Sun, and they move slower when they are far away from the Sun, because the gravitational pull experienced by them is stronger when they are near to the Sun, and it is weaker when they are away from the Sun. This can also be explained by Kepler's second law of planetary motion. When a spacecraft is launched from Earth, its forward velocity combined with gravitational pull cause it to move in a curved path, and it keeps on following the same path, obeying Newton's first law of motion. Locating trajectories between Earth and Mars requires some accurate timings and calculations. Let's say a rocket is moving from an initial position A to a final point B. Now, this man wants to shoot down the rocket. If he aims towards the initial position of the rocket, he would miss out on the rocket. Why? Let's see. The time taken by the bullet to reach the initial position is t. Now, in the same interval of time t, the rocket would have moved ahead with a certain distance. So, his bullet would miss his target. And if he aims towards the final position of the rocket, he would hit a bull's eye. The same case applies for a transfer of a satellite to Mars. To make sure that the satellite and Mars reach at the same position at the same time requires the satellite to be launched at a particular window of time. This is also called the launch window. A Hohmann transfer orbit is a half-elliptic orbit around the Sun which joins the Earth at the perihelion at the start of the transfer and the Martian orbit at the aphelion at the end of the transfer. The spacecraft is lifted off a launch pad and its rocket accelerates in the direction of the Earth's revolution around the Sun. The spacecraft is already at the perihelion position and it gains enough energy from the acceleration of the rockets such that its new orbit would have an aphelion at a Martian orbit. The spacecraft is inserted into the interplanetary trajectory at a correct time in the launch window so that it reaches Mars accurately. In order to get captured by a Martian orbit, the satellite needs to decelerate. This is done by firing the thrusters in opposite directions. In this way, we can reach any outer planet in a fuel-efficient method.